So when you're constructing a problem like this, and you want to run it through reinforcement fine-tuning with GRPO, the DeepSeek formula, there are two key components you need to construct. A data set, at the very least, with some prompts. And the second, and these prompts, ideally they're well structured, there's a bit of diversity, but what you're really looking for is very high quality inputs, right? Just 10 is sufficient. Then, and some sort of diversity, so the model can learn a generalized strategy to solving your problem. And the second part is the verifiable deterministic reward functions. And I know people have many questions about this, and I'll show you what it looks like 2 slides from now. But the idea is that, since you don't have a ground truth to compare to, you need a way to at least tell the model in some capacity whether it's doing something correctly or not. And you want to be able to do that in a very objective way so that every time the same output is produced, you give it the same score and there's no non-determinism. So it knows for a fact that this is like the score it's going to get. And by keeping it objective, we eliminate noise, should help train the model faster. So let's talk about how we would create a data set for this task, because that's what we had to do, right? So when it comes to data set creation, here's the easiest strategy that you can think of for a task like this. This is what we did. We went to GitHub, a treasure trove for open source code that lives out there. And we searched through a bunch of open source repositories that have some sort of Triton kernel implementations. And there are actually quite a few that have, people practicing, just like how to write Triton kernels, so people actually like using Triton kernels for their specialized tasks, so on and so forth. And what you can do is you can actually like grab these kernels out from these code repositories that are open source, and you can run them. And what's really nice is that most of the times people write like a PyTorch equivalent and then a kernel equivalent, and then write a test case to show that the output is the same. So you can verify that it compiles and the kernel is valid. Now, once you have that, remember, this is actually sort of like the output, right? But what we want is an input we can pass to the model to actually generate these kernels. So what you can do is one of two things from there. I did like mostly the first, which is convert the Triton kernels to Torch code yourself. Or if they have Torch code in these repositories for these kernels, then copy them over, fix them, modify them to make it make sense. But if you're not an expert, we can always send it to, let's say, like Llama 370 billion and have it generate the PyTorch code for you, and then you can modify and fix it as you want.